There we go, and we're recording now. So, okay, so welcome to the Security Working Group meeting for December. It's great to have you all here. The first quick thing I'd like to do is to request the group's approval to the meeting minutes for last month's meeting, November 8th, 2022, and they're linked on the agenda. So if everybody agrees with that, then we will consider them approved and move on to our next item in our agenda. They've been added to the GitHub repo for a group. Okay, so we have today a presentation from new members of the group, Gianmarco and Benjamin. So I'll let you guys introduce yourself and give you the floor if you want to present anything also visually. Go right ahead. Thank you.
Okay, I'll start, introduce myself, and then Ben can introduce himself, and then I can start the presentation, I guess. So we have so I'm Gianmarco Pisarelli. I'm a tech lead at the AMRC in Sheffield, as the Advanced Manufacturing Research Centre. And last year we joined the ROS Industrial Consortium, and I'm sort of the representative, the one that sort of talks with the rest of the European consortium. So my task is to sort of look at what we call novel robotics, which is anything that is not conventional industrial robotics, but it's something that's more sort of academia based, and we try to push it towards industry. And that's sort of my role. Well, the reason why we're here is that one of the projects that we started this year is involved the transition from ROS 1 to ROS 2. Because I've got quite a long experience on ROS 1, but I never touched ROS 2, and it was about time for us to start. So I don't have much, if any, experience in security, while Ben, I think, comes from the sort of opposite end of the spectrum. He had a bit of experience in ROS, but it's more of an expert in security. So I designed one work package on the project that we're working on, just to look at the security sort of side of ROS and how that's implemented, and just if you could see almost like a trade study to see the strengths and the weaknesses, and that's what basically Ben has done as part of this project. And I think I can leave that to you, Ben, so you can introduce yourself and maybe start that presentation.
Yes, thank you. Hello, I'm Ben Morrow. I've been as Gianmarco said, I've been looking into the using the ROS2 security architecture practically to secure a robot in an industrial environment where maybe it's more important than sometimes that things are actually secure. And yeah, I mean, I found a couple of problems, but it's certainly a big improvement over the ROS 1 situation where there's no security at all. So so I've done a presentation. So I think I'll just start and explain things as I go along. It's probably easiest. If I share my screen, I can find the right buttons to press. Not that one. Let's try that one. Can everybody see that?
Yeah.
Yeah.
Okay.
Cool. Okay. So my part of the project was basically to take a robot that had been set up to run with ROS 2 and to attempt to implement the ROS 2 security. And in the course of doing that, obviously you have to set up the key stores and the certificates and everything. And I ran into a problem, which I will explain. So to start with, I mean, I don't know how familiar everyone is with it all, so I'm going through it rather basically. Do excuse me if I'm telling you things you already know, which I probably am. So ROS 2 security is based on DDS security, and the DDS security architecture is based on X509 certificates, OpenSSL certificates, So DDS, the way DDS does security is there are two root certificates. There's one that certifies identities and there's one that certifies permissions. And as far as DDS is concerned, they're completely separate. The trust chains to certify an identity and a permissions document are not related. They don't need to be connected at all, which is slightly complicated. But that's how the DDS people chose to do it, and so that's the framework that ROS has to work within, given that you're using DDS as your middleware. The ROS security tool, when it sets up a key store, obviously because you thought that this was too complicated or something, it actually unifies those two certificates, the identity and the permissions certificate authorities, into a single certificate that lives at the root of the key store, and it creates symlinks to them in the key store so that it fulfills both functions. So all the Enclave certificates that certify the identity of the nodes are signed by the certificate, as are all the permissions XML documents that say what the nodes are actually allowed to do. They're all, in the end, signed by the same certificate, which is trusted to do both jobs. Normally, this isn't a problem. The nodes publish their permissions documents. The other nodes receive them. They verify the signature, which goes against the authority that they have. That authority is set up for them as the permissions authority, so they're quite happy to accept the permissions documents, and everything works, and everybody's happy. However, what happens if you have an enclave that decides to misbehave? The whole point of having security is so that you can start to separate the different parts of a robot from each other. So, for example, if a user has, they're running RViz on their laptop, and you maybe don't quite trust their laptop, it's a user's machine, but you want to give them read access to the robot. So you start setting up ACLs so that they only have read access, they can't move the robot. Whatever, there are all sorts of access control decisions. If we have access controls, we need to be able to use them, and they need to work. So assuming that the permissions have been set up to allow different parts of the robot different amounts of access to each other, the nodes are not supposed to be able to do anything that the properly signed permissions document says they can do. This is where the problem comes in. If we have a compromised node and it's trying to do something that it's not allowed to, what it can do is this. The node has access to its Enclave certificate private key. If it takes that private key and the Enclave certificate and it signs a new document. Hello, yes, Eduardo.
Please, sorry, go ahead, and then I will chip into this problem, because I think it's interesting what you're explaining here. I'm from a Proxima. We do fast DDS. We do the underlying middleware. Yes. I think I would like to chip in after you finish.
Yep. Okay, that's fine. Hang on, I'll carry on then.
Thanks.
Where's my window gone? Let's have that window. Okay.
We can still sit there.
Yeah. So the node has created a permissions document, giving it, any permissions it likes, any, permission to do anything it wants to do, and it signs that permissions document with its own certificate. It hasn't got the certificate authority key. It can't sign it with the certificate authority key, but it can sign it with its own certificate. And then it publishes that document over DDS, and the other nodes receive it, and they attempt to verify it. And because there is a chain of trust down from the joint authority through the node's own certificate to the new document, they believe that it's authentic. So the Enclave certificate is signed by the joint certificate in its role as identity, but the other nodes are trusting it in its role as permissions, and so the certificate is the malicious document is believed, even though it's not supposed to be, because the chain of trust goes through the identity certificate. If the solution, the straightforward solution, is to have two certificate authorities, as DDS had in the beginning, And then, although the node can still sign a document with its enclave certificate, that document is no longer trusted because the enclave certificate is no longer signed by the permissions authority. It's only signed by the identity authority, which, restores the security, restores the ability to set proper ACLs on the nodes. So, I mean, I actually, worked this out when I was thinking about rollover of certificates and signing certificates with other certificates so that you can roll over the root and so on. And I was thinking backwards through the problem. I said, actually, I think I can do this here. I think I can cheat. I think I can get around the security. So I actually set up a script to demonstrate it because I wasn't entirely sure it would work. So this is I don't know how well it'll come through, but this is a video of actually running a test. It sets up a clean if it's going to play, which it doesn't seem to want to. That'll do. Okay, so it creates a new key store, sets the environment variables, creates a key store using creates some genuine permission documents that gives so the way this, you can't see it, I can send you the script later so that you can, demonstrate it for themselves. But the way this is supposed to be set up is that the talker is talking and the listener is not allowed to listen. It doesn't have permission to listen to the talker. So it runs the nodes, they find their security, and the listener is not allowed to listen. The listener is correctly failing to be able to subscribe. The talker is publishing, and the listener is not allowed to subscribe. Then, acting as a malicious listener load, I take the permissions XML and I just change the topic. So the listener was allowed to subscribe to something else, and it just changes the topic to the topic it's not supposed to be allowed to subscribe to. It re-signs the document with its own enclave key. And then when we run them again, it's successfully able to subscribe, even though it's not supposed to be. Okay, I think I'll stop there for a second because if you had any questions, I mean, there were a couple of other things that might be worth talking about, but I think that's worth maybe discussing for a minute. Do you think? So. Hang on, sorry, I can't hear you.
Can you hear me better now?
Oh, that's better. Yes, thank you.
Okay. So for the X509 certificate standard, there is a flag denoting whether the certificate is authenticated to be a certificate authority. And so particularly like for web development, when you have CAs signing SSL certs, you want to be cautious that that CA isn't authenticating another CA to extend the chain of trust further. To truncate that, the CA can deliberately choose to only sign certificates that do not have the certificate authority flag set. So then the chain of trust truncates there. From what I remember, I thought we were using the X509 Python library to deliberately disable that flag for certificates for the enclaves. But maybe did you find that wasn't the case?
No, there's actually when you sign the permissions documents, you're using SMIME. The permissions document is not a certificate; it's just an XML certificate signed with SMIME, which means that it is not supposed to be signed by a certificate authority at all. It's supposed to be signed by a plain endpoint certificate. So the
signature for the so this is an implementation error in the DDS vendors?
No, it's not. It's a possibly a misunderstanding of the function of the function of the different certificates involved. I'm not sure. So as the ROS2 security tool creates the key stores and so on, this certificate authority certificate has CAPARTH 0. It's not allowed to sign any sub authorities. When the permissions document is signed directly by the certificate authority, that's not actually how it's supposed to work. You're supposed to always have an intermediate certificate by X509 design. So the idea, well, if you go back to the original, the idea here is that normally you would have the permission certificate authority, and then you would have sub-certificates issued perhaps to individual administrators who had authority to sign permissions documents, a personal certificate for a systems administrator, and then they would sign the permissions document with their personal certificate. So this Enclave certificate here is acting like a personal certificate for an administrator with permission to do the signing, even though that's not in fact what it's meant to be.
That's not.
Am I not explaining correctly? This
So
last link in the chain. Sorry.
Yeah, the
yes.
Enclave certificates, or sorry, the Enclave certificates shouldn't be able to sign anything. If they're signing a SM signature, then that signature doesn't match with the root CA, though.
But there's a chain of trust. I mean, the Enclave certificates have to be given permission to sign data. They have to be given the flag that says this certificate can sign data, because you can't do anything at all if you don't have that flag. You can't. You can't do the SSL handshake unless you have the flag that says you can sign data.
No, you should be able to TLS. You can do that if you're just a RSA or a
you need
elliptic curve key, public key. You just have your key pair, and it doesn't mean that anything you sign, you can't sign any of the certificates, but you should be able to
hang on,
sign the Diffie-Hellman exchange.
I think you still need, well, certainly as ROS2 security creates the certificates, that's not implemented. Maybe it could be fixed just by changing the flag. I didn't think that you could. I thought that you actually needed the sign data flag in order to do the certificate exchange, because you have to sign Diffie-Hellman stuff as part of the exchange, don't you? Even though it's only temporary, you still have to sign it.
That's not the same.
That's not the same flag.
The certificate authority flag doesn't disable you from doing Diffie-Hellman.
Where are these? Where are these documented? Is it documented here? Here.
All right. So in the SROS2 key store underscore key store PY on line 113, we have the utilities for creating build a key and certificate, and so we specify that the C is true.
Hang on,
here. Cert, line 114.
Hang on, you're looking here in the keystore.py in SROS2.
Yeah. And then line 114. This is the case where the CA certs are acting as certificate authorities, and if we found the similar function for invoking an Enclave cert, I think that is not set.
No, but you don't have to be a certificate authority to just sign a document. You only have to be a certificate authority to sign a certificate.
Why is the chain of trust for the signature accepting signatures that are not from the certificate authority?
If you look at the chain of trust, it's only the first. So this certificate is not a certificate authority, but it's allowed to sign documents. If there was another,
it can sign thing, but why is validator taking that, accepting that? It should look at the certificate, the X509 certificates for the Enclave certificate, and realize it's not a CA, so it can't
you don't
sign.
need to be.
Even if it
You
can.
don't need to be a CA just to sign an XML file.
I know, but why is it accepting its signature if it's not set as a signature as a CA? That's my root issue.
Because it chains up to a CA that it trusts.
But the chain is broken right at the second link.
Hang on, I'm not. There's only one link. There's a CA here that we trust that has a CA flag.
All right, I'm saying the arrow. So the first arrow is the first link, and then the second
Okay.
arrow is the second link. I'm saying that second link is not valid, and that the signature is coming from a certificate that is not signed as a to be a CA.
You don't need to be a CA to sign an XML file.
I know you can sign it, but why is the validator accepting?
I mean, the validator accepts that. That's part of X509. That's how X509 works. You never have to be a CA to sign an XML file.
Okay, all right.
I mean, that's
different.
If you were signing another certificate, then you have to be a CA. But you're not signing a certificate. You're just signing a document.
Okay, I thought the evaluation for the permission files were going through the same format as if it was a certificate.
No, they're not. I think that's the problem, that they're not, and they never do with X509.
Okay.
I mean, looking at the flags, there's this flag is the one you're talking about, isn't it? This digital signature flag. You're saying, can you turn that flag off on the Enclave certificate? And I think the answer is you can't, because you can't do anything without it. You can't prove your identity without it, because the way you prove your identity is by signing stuff.
Why is it a flag then?
Because the CA shouldn't have that flag. No, I can't remember. There are certificates that don't have that flag. I think intermediate CAs don't have that flag because they have key sign instead.
Gotcha.
Which says that you can sign certificates only and not documents.
Interesting. Great point.
I mean, it's not very difficult to fix. Obviously, you just construct the key store differently so that it has two separate routes. I mean, because it's all done with symlinks, it wouldn't even affect anything very much.
Yeah, we just did symlinks in the beginning to figure if people want to plug in their own certificate authorities, it'd be easier to do that without having to.
No, I can see that. It seems complicated needing to have two authorities, but I think DDS were right. It's necessary.
Yeah, it's definitely necessary to do that. Yeah. It's actually a very good catch, I'd say.
Okay. I mean, it would be nice to be able to have a single authority that you could change from, but it's difficult to see how it works because the simple act of signing a certificate with the permissions authority gives that certificate permission to set any permissions on the whole robot. It's actually quite a serious act, signing something with the permissions authority. It gives that certificate the owner of that certificate very broad rights to do all sorts of things.
Yeah.
Yeah. Okay. Hang on. So there are a couple of more minor questions to do with how the key store was set up that I came across. Is it worth discussing them now, or is there anything else that was wanted to discuss in this meeting? I don't know. What do you think?
I added a point that might be related. We did.
Yes.
I don't know if you have the agenda there. It might be somehow related or relevant. On ROS2 design, I will just share my screen. Okay.
Yeah. I'll
very
stop sharing.
quickly. A second. So I don't know, year and a half ago or so, we tried to push for a new feature on ROS2, which is to store the private key of the enclaves in a hardware secure module, or rather have the ability to do so using this PKCS 11 protocol. We got as far as making a design proposal here, and then actually we have a pull request on RMW Fast RTPS, which is the connector between FastDDS and ROS2, where we implemented this. And in our own fork, we have it implemented, and we have some clients actually doing that. I don't know if you have seen this before or not, but the thing is that you store the private key on a hardware secure module that then the RMW can retrieve when need, or FastDDS rather, can retrieve when needed using a PIN or kind of a password, right? So it makes systems more secure, as as far as all the keys, instead of being kind of in the clear on the host, they are on a hardware that is specifically designed to store encrypted keys and so on, right? And I think that could be relevant for what you were saying before, right? In a way. And we actually were intending to try to, or push that forward. I mean, do whatever we need to do to make that feature come into the mainline, meaning decide on interfaces on the upper layers and so on, with the working group here.
Yeah, I don't know. I mean, yeah, that sounds like a certainly sounds like a useful feature. I mean, one of the weak links here is that you end up with these identity certificates spread on machines that might be anywhere, and you need to, that takes.
Yeah, exactly. You end with these things, right?
Yeah,
on the
I mean,
keyboard.
yeah, you have the Enclave certificate private keys are definitely quite a weak point. I mean, they're easy. You need good revocation mechanisms, don't you? Always, which I'm not sure has quite been thought about, but I didn't.
I don't think it's very thought about on ROS2. Rather, I
no,
don't think.
To be honest, I don't think it's been very thought about with X509 altogether. The question of revoking a certificate under X509 is very difficult to resolve.
I'm not that familiar, but
No,
I think there are things on DDS that can be done to revoke things.
Yes,
as far as I remember.
Yes, I didn't look into that. But yeah, no, it's certainly an important question. What happens when a certificate's compromised, and how do you deal with that?
Yeah, the idea is here to put it on a hardware secure module, right? So you can have it on a USB stick even, right? And then you unplug the thing, and then all the security falls down, right? That's the idea. That's a feature we want to push forward on ROS2.
Yeah. I mean, that actually ties somewhat into the next thing I was going to try and talk about, which is to do with generating the Enclave certificate.
Sure.
So, if I share screen again. Why does it keep changing its mind about which one's which? So, here, this one. So normally, when you generate a X509 certificate for a web server or whatever, you start by generating your private key locally. You generate a public key from the private key. You generate a certificate signing request from your public key. You send that off to the certificate authority. They sign it, and it comes back as a certificate that you use. And your key always stays in your possession, and their key always stays in their possession, and you never have to switch. You never have to move keys from device to device. I mean, X509 have put a lot of work into making sure that the certificate request and the certificate are both safe to transport, in fact, in the clear if you want to, as long as you end up with the right thing signed. The way ROS2 security does it is when you run create enclave, it creates the enclave certificate and signs it in a single step, which means that you then have to choose, am I doing this on the machine where it's going to be used, or am I doing it on the machine that has access to the authority key? They ought to be separate machines.
Yeah, I actually always thought, and I think that's maybe the documentation is lacking a bit on that they are supposed to be run on a separate machine, not on the robot, and then deployed on the robot, right?
Absolutely.
That's what our clients do always, right?
Yeah, no, I think this is quite a, I mean, I think it's maybe a little bit of a an approach change, you know, that you need a security management setup that is isolated from the robot and has private keys for the certificate authorities and everything else. So yeah, anyway, this is where I came to, you know, where do I run this command? If I run it in my signing system, then I have to transport the private key back to the robot, which is bad security practice. If I run it on the robot, then I've got to put my certificate authority key on the robot, which is even worse. So, I mean, you know, it just needs options to generate the request and do the whole dance in the right order with everything, you know.
Yeah, the processor of this tooling that I wrote with Keymint and CalmArmor, that was my initial approach, where I sort of have a workspace, and everything was sort of staged in the file system, and so you could have an intermittent stage with the certificate requests, signing requests, and then so then you could like kind of manage that out of band from the CLI based on how you were exchanging these files, and then that way, like you said, the private key for the robot would never have to be. It could be generated on the robot and never like sent off the robot. Which is
I mean, presumably, if you're talking about these hardware security modules, I mean, I don't really know how they work, but I think quite often they insist on generating their own key, don't they? And they don't ever give it to you.
Yep.
So you know, you'd have to use the one that it made for you. So yeah, I mean, it's just, you know, it's all detailed. The architecture is all there and can be used, and you know, it just needs, I think it just needs a bit more. Yeah, I mean, and then some minor details, you know, like none of the private keys are stored encrypted, and they can't be. You know, they really should be. A certificate authority private key should never be on disk unencrypted. You know, and just the idea of having a separate signing key store from your running key store, and tooling that can pull out the right files. If you just run through the tutorial for the setting up the security, you end up copying your certificate authority private key onto the robot, and that's not really something we want to encourage.
No.
really.
Yeah,
they should probably be covering the Enclave.
Yes, but even if you just copy the Enclave directory, well, yeah, you can just copy the Enclave directory and that, but then you have to follow the symlinks because it's all symlinked. You have to resolve the symlinks. If you just copy the Enclave directory, you just get symlinks that go nowhere because they link out to the public direct. It's just detail. It just needs to, you know, it just needs a bit of tidying up.
Copy the public and the Enclave and leave the private.
Yeah, I just think you know, it wasn't entirely clear. If you just follow it, it just says skip the whole directory, which works, but is not. Yeah. Anyway, that was all really just, you know. I mean, the conclusion I came to really is that if you take it as it stands right now, you can generate a key store with a single enclave which has full robot permission. And then you treat that whole key store as a shared secret and just copy it to all your robot nodes. Even that gives you a significant security increase over ROS1 or unsecured ROS2. You know, you've got pre-shared secret level security. You've got no security barriers between the different parts of the robot, but you've still got good isolation of the robot from the outside world, which is that's a good step. But I think, you know, getting some level of isolation between the different parts of the robot is perhaps worth achieving, especially because DDS supplies it.
From your experience, I meant, like, this is probably a pre-existing problem that many other like IoT vendors or even web-based ecosystem has probably tackled. Like, I think there's key management frameworks. I think trying to remember the most popular one is like from Key.io or whatnot. But in terms of doing all the logistics and transporting and managing certificate signing requests and having a consolidated API to do that kind of middleware exchange. I think this is something that maybe we're better off leaning on that infrastructure rather than, you know, home brewing our own stuff in Python here.
Maybe. Yeah, I don't know. I don't know what's available, but yeah, no, certainly if there's a tool that does the job, it'd be better to use it, wouldn't it? Anyway, that was all from me, really. I don't know if anyone has anything else.
Can you post these slides and then your script as well? One of the things I think I'd like to do is
what's the best place to send them? I mean, we're new to this working group. Where do things get posted?
Yeah,
I think the best thing would be is to maybe file a new ticket on the ROS, and then you could like attach your PDFs and your script, as well as like a summary of the main pain points.
Yeah.
That way we can follow a long-term discussion on.
Yeah.
Yeah, we'll also add them to the meeting minutes for the group.
Yeah. Okay.
Should we have some action point to do about this? At least put a note on the documentation saying, do not deploy the CI certificate private keys into the robot, something, right? I don't know. It's kind of the point of the working group, right? To kind of have action points as a result, so we can improve things. So I don't know what you guys think. I think we could take on that, improving a bit on the ROS 2 documentation. Even taking a look at the tutorial, maybe if we can, you know, split the enclave and the key store. You can, you know, having one for signing and one for running, and then, you know, saying that you should deploy the one from running. This is still not perfect because of what you described, right? That you can still sign things with a malicious node, but it's definitely better than what we have now. So
yeah, I think the tutorials are quite important, because I think quite a lot of people will just follow the tutorial and not really think any further than that.
Yeah, exactly. So, and that's kind of the point, right? That we need to encourage the use of security, because from our experience, and we do some consultancy on projects using ROS 2, actually everyone says that they're very concerned with security and nobody ever uses it. So kind of need to make it very easy for them in a way.
Yeah, no, yeah, that's definitely.
And regarding this hardware secure module feature proposal, I don't know how, to be honest, Iker, the person that opened the pull request, used to work here, and he was the one attending the security working group meetings. And then we have had a period where we are not attending. So I actually don't know what's the process to kind of move things along or try to work on things. I don't know if we should have the discussion on the design. Should we prepare a rep proposal, like, which kind of seems the trend right now in ROS 2? I don't know. It's kind of part of the reason why I joined today. Sorry, Ralph, go ahead.
The design docs, the ROS 2 design docs, that's currently houses the equivalent of what would have been the REPS, the ROS enhancement proposal so far, but on the security front. So there's the 3 design docs on ROS 2 design that you can take a look at, and then I would propose maybe modifying that, opening up the PR, and then that way we have like a more concrete high-level overview of how it's expected to integrate with the rest of the user experience. Like, are they controlling where the keys are located via environment variables, or is this some extra command logs? How is this expected to be found in the RMW layer to like notify the DDS layer where the keys are? Or is it a file path or to the unique Linux resource, or is it like a specific UUID? I'm not sure how that software or hardware boundary is communicated to the middleware. So I would recommend going over the design docs currently and then opening a PR and modifying them to where
yeah,
you think
rather updating this PR that yeah, okay. I'll try to update
and
this
and then once we have the design docs kind of merged, then we'll proceed with like the implementation and what kind of extensions we need to do with the command line.
Okay. Okay, I will try to then I don't know, go over this pull request again, maybe if there needs to some update or something. And should I just pin you, Ralph, to take a look at it, or should it be someone else? I don't know.
You can ping me. I think. Do we also have a security tag? I thought we had a security group, working group @ where we could ping people, but maybe I'm forgetting about that. Or a team, GitHub team thing.
I have no idea.
I think Kyle who was working at Canonical knew about that. It's something we might have to dig into. But yeah, there used to be a way to notify everyone that's a member of the working group on the GitHub org.
So I invite you also to join the matrix chat for the group.
Oh, yeah.
And that's an easy way to communicate with everyone.
Thank you.
Yeah, I send the link on the
Yeah.
That's a very good asynchronous channel.
This is great. Okay, thank you. I don't have any of these apps installed, but I will look at it. Okay. Thank you. Yeah, I can write there. Yeah.
Okay. I don't know if you guys have something else. We're almost at the time. And it's a great thing that now we have like asynchronous channels to keep working on this. So we can do that.
Can we put on the meeting notes the action point of updating the tutorial? If you can point that to me. Or should I just do it?
Benjamin, when you create that ticket, please at me at Raphael. I really like to maybe generate an IPython notebook using our current API to replicate the exact scenario.
Okay.
It looks very interesting. Thank you for bringing it up.
Okay. Cool. Yes, I'll do that.
Anything else?
Not from me.
I'm sorry, Benjamin. I missed your beginning, your introduction. Where are you from?
I work at the AMRC in Sheffield. I'm a software developer primarily, but with a focus on security. Approaching this from the kind of the IT side rather than the OT side.
Do you have clientele that are interested in getting in using ROS, or is this like a in-company or in-house effort in looking at
I think it might be better for Gianmarco, can you
Yeah,
field that?
sure. So yeah, we sort of, my role is the one I mentioned at the beginning, but as you said, you probably missed it. My role is to sort of look at the what we call novel robotics side of robotics, which is anything to do with robots that's not traditional industrial robots. So like the traditional like cooker robots that just do like KRL, or like ABB robots that only use proprietary languages. So we look at we're trying to push this new. So by the way, I don't know if you know what we are Catapult Center, the MRC. So I don't know if you know what Catapult Center is. So basically, partially funded by, we are owned by the University of Sheffield, but are partially funded by the government through Catapult fundings, and we try to sort of push research for the UK sort of market. As part of one of these fundings this year, we've done a few projects on ROS1, but now we're trying to push the use of ROS2. And then ideally we can sort of publicize or disseminate all those information to like industries around the UK. So predominantly we are a research center, and one of our goals at the moment is to push ROS more towards industry, because you guys probably know better than me. It's used a lot in academia. Industries are quite reluctant, and I guess that's the reason why ROS2 was born, to answer all the issues of all the problems that industries had with ROS1. So now we're trying to sort of disseminate, like study ROS2 a bit more, understand how the weaknesses and strengths, and then push that dissemination to the UK industry. So yeah, we're going to do it as a company sort of wise. What we're going to try and work on ROS2 a bit more. This is the first project that we officially done on ROS2.
Could you drop a link to your organization? That sounds pretty interesting.
Yeah, definitely. So we're quite big. I'll find the link to the website. We've got different centres across the UK. We're based in Sheffield, but we've got like different centres. So we looked at what we call integrated manufacturing, which is basically integration, control system, robotics, security, IoT, and factory of the future sort of things. And then we've got the centers that look at composite, we've got other centers that look at casting, medical. So yeah, we've got different centers. We specialize in robotics. So that our center, but we've got like different centers that look at different things.
Awesome.
And from last year, we joined the ROS Industrial Consortium. So with the hope of gaining more knowledge from you, but also sharing it with you guys.
All right. I hope to see you around the Matrix channel. We can continue iterating on these fixes really soon.
Yeah, definitely.
Yeah, and for the action points, I feel free to add anything else agreed on the agenda. Usually to prepare the minutes, I go by the recording later on, but just since we're all here together, if there's anything else you decided to take upon yourself, like I saw Eduardo added improving security examples in ROS2 docs, so.
I'm going to add to revive this pull request in ROS2 design.
Excellent.
You can add me to looking into the splitting the CAs and verifying the issue with the chain of trust. I'll definitely look into that.
Okay, great. I put it into All right.
Okay.
Anything else?
That's it. Thank you so much,
Thank
guys.
you so much. Yeah, thank you guys.
Thank you, guys.
See you next time.
See you.
Thank you.
Thank you for having us. Thank you. Bye bye.
Bye.
No.